Okay, so this is an example of the combination circuit. What we have is a 12-volt battery connected to a 400 ohm resistor, and then it splits off and you have a 500 ohm resistor and a 700 ohm resistor in parallel with each other, and then it heads back to the battery like this. You have 12 volts here, 400 ohms, 500 ohms, and 700 ohms. Okay, so basically whenever you have a combination circuit, you're going to want to work from the inside out. So you want to look at what kind of combinations do you have. So what we see first is that the 500 and the 700 are in parallel with each other, and I know that because they start and end at the same points. They both start here and they both end here. Okay, so what I can do is find the equivalent resistance of those two by themselves. So I'll do 1 over the equivalent resistance, since they're in parallel, is 1 over 500 plus 1 over 700. Okay, so common denominator here would be 3,500. So I'd have 7 over 3,500 plus 5 over 3,500 equals 12 over 3,500. And then to find R equivalent, I need to flip that. So R equivalent equals 3,500 over 12, okay, which ends up being about 290 ohms. So this combination of 500 and 700 is basically the same as a 290 ohm resistor. Now that is in series with the 400. So I can put those together and find R total by saying I have 400 ohms in series plus 290 ohms in series, and get 690 ohms. And then I total will be the 12 volts divided by the 690 ohms, which gives me 0.17 amps. Okay. Now I can set up my chart, R, I, V, and P. And what you need to do is kind of go back to the circuit and think about how current flows through it. So if you look at it, all the current flows out of the battery and flows through the 400. It can't split up before it goes to the 400. All the current goes through there. So I'm going to put that full 0.017 amps going through the 400 ohm resistor. So I have 400 ohms, 0.017 amps. Okay. I have the 700 and the 500 ohm resistors here, which we'll deal with in a second. But since we have R and I for the 400 ohm resistor, we can find its voltage, and we find out that that's 6.8 volts if you multiply those together. Okay, so out of the battery came 12 volts. We've used up 6.8, which means we have 5.2 left to work with. So we have 5.2 volts here and 5.2 volts there because they're in parallel, so they both share that voltage. Okay, and then we can calculate the current just by dividing the voltage divided by the resistance. So this one is about 0.01 amps, and this one is about 0.07 amps, 0.007 amps. Okay. Since these two add up to the current from the 400 ohm resistor, that makes sense because all the current flows through 400 and then it splits two ways. Some of it goes through the 500, some of it goes through the 700. So they should add up to equal the current through the 400. Okay, and then remember, to find power, you just multiply V times I. So we'll leave that as an exercise for practice. Clearly the 400 ohm resistor is going to use up the most power here just by looking at the numbers. So this is an example of a combination circuit.